Configuring Network Load Balancing, or NLB, in Windows Server 2012. So in this nugget and the next one actually, we're going to look at methods for load balancing and failover in Windows Server 2012. Now, what we're doing in this nugget with NLB is certainly not a new technology. It's existed in Windows Server for many versions. You probably have already used it in a laboratory or production environment. We're going to focus first of all on understanding the basics for those of you who may be a little rusty on NLB, what it is, what it's used for, and very importantly, how NLB differs from failover clustering. NLB is considered by Microsoft to be a clustering technology, but it is indeed separate and distinct from failover clustering. We'll then begin a deep dive consideration into NLB proper, looking at the prerequisites, what is allowed and what isn't allowed in deploying an NLB cluster. And then, of course, in our demo, we'll implement a multi-node NLB cluster, and you'll find out how it works using both PowerShell and GUI tools. And along the way, you'll pick up all the relevant vocabulary, things like affinity, port rules, I'm not doing Old English here, this should be an R, not an F, and operational modes. Without any further ado, let's get started. The first question we need to answer is, of course, what exactly is Network Load Balancing, or NLB? In a nutshell, friends, NLB is a free in-box technology that we can use in Windows Server to scale up and scale out a web infrastructure. Now, that's a definition and a non-definition at the same time. Remember that to scale up means to increase the capacity of a single box. When we talk about scaling up a web server, we may be talking about adding additional RAM, CPU resources, network, or storage to make that box more powerful. When we scale out an infrastructure, it typically involves the R word, redundancy, setting up multiple instances of the same type of server for the purposes of load balancing or spreading the user load around, and failover. That is to say, if we lose one box, how can we ensure high availability for our users? Network load balancing actually accomplishes both goals. We're scaling up our web servers because each web server presumably can handle more concurrent connections than it could otherwise. We're scaling out and providing failover because the more redundancy we have in our infrastructure, the more capacity we have to recover from an expected or unexpected outage. Alright, so why is network load balancing referred to as a clustering technology? The main reason, friends, is what we're doing is aggregating between 2 and 32 web servers and presenting that farm, that server farm, technically called an NLB cluster, to our user population under a single IP address and host name. So as far as our connecting users are concerned, their browsers, their DNS resolvers, and their Windows software, or for that matter, whatever their OS software, knows about only a single IP that actually is a virtual IP because it doesn't map to a physical MAC address. Each web server in your web server farm, of course, has its own static IP address and its own MAC address. We'll get to some of the specifics there a little bit later. But the problem that we want to solve is how can we avoid overburdening a particular web server? Now, what you're seeing, really, let me introduce this whole diagram, is a simple Visio drawing I've put together that shows a typical N-tier, or in this case, a 3-tier architecture, client-server architecture. Think of applications like Microsoft SharePoint Server, Exchange Server, Link Server. All of these use the N-tier model, where we're providing different layers of functionality here. And typically the front end are going to be your IIS web servers that present the application to the users themselves. Our middle tier are where our application servers exist, where the main input, output, and business logic happens. And then in the back end of things, we have, in a Microsoft world anyway, SQL Server that's fundamentally storing the data that's used by the applications and the web servers in one or more databases. Now, why is NLB synonymous pretty much with web traffic, with HTTP, with FTP, with basically IP traffic? We'll get to this more as we move along, but I'll let the cat out of the bag now by saying that NLB in Windows is optimized for what's called stateless traffic. HTTP, by and large, is a stateless protocol. The idea of statelessness, not weightlessness, but statelessness, means that under normal circumstances, it shouldn't matter which front-end web host a user's connections go to. HTTP is an awfully connection-rich protocol, and you can have connections, multiple connections, and reconnections happening all the time. NLB is designed for that kind of thing because it's assumed that your NLB nodes, as they're called, your web servers, all contain the same data. They should be kitted identically as far as their IIS websites that they're hosting. Now, for more stateful applications that require a persistent one-to-one between the client and the server, even the web server, NLB isn't your best choice. There's some play in NLB configuration where we can adjust the affinity of network load balancing more towards a, quote, sticky environment, but essentially we're looking at NLB optimized for stateless environments. That's why network load balancing is not a good fit for database services and file share services, because those, by their definition, require a stateful session. Think of Hyper-V virtual machines. That's the ultimate example, it seems to me, of a stateful connection. You need a persistent connection to that VM to do your work. So on that side of the fence, SQL Server, let's say, the way you scale that out is using failover clustering. And we're not going to burn much daylight in this nugget on that because we're going to actually cover failover clustering in a separate nugget altogether. Enough of the preliminaries. Let's start to deep dive into this. NLB notes. Here I've put together a punch list of facts and factoids that you need to know for, at the very least, your 412 certification exam success. Some of these points can come back and bite you, though, in production, so it's important information to have anyway. First of all, the magic number with network load balancing is 2 to 32. Each NLB cluster can contain between 2, obviously you need at least 2, and up to 32 nodes. If you understand NIC teaming in Windows Server 2012, it's the same load out there. NIC teaming supports between 2 and 32 network interface cards. Can you combine NIC teaming with NLB? Absolutely you can. Can you scale out NLB clusters? Yes, you can. In fact, we'll talk about that in just a little while. As I said, NLB is optimized for stateless or HTTP connections, not stateful, that require persistent connections like file services and database services. Now, NLB, haven't mentioned this yet, has some intelligence. I put this in quotes because, generally speaking, it's not a good practice to personify non-living things like computers, but I think you get the point. NLB uses algorithms. It uses mathematical formulae to determine, number one, which nodes are part of the cluster, number two, which nodes are alive and which are not alive, number three, priority, when incoming connections come in. That's really where the load balancing comes in. Let's say you've got 3 web servers. Your NLB layer is responsible for taking an incoming connection and determining which of your NLB nodes is best capable to handle that connection. Now, we're thinking of things like, what is the current connection level or queue in each of those? That's an easy way to make that decision. You can also assign as an administrator, again, I get a little ahead of myself here, priority numbers such that if you have maybe a server that's a little beefier or more available than another, you can put that at a higher priority level than another box. So you have some ability to control how NLB uses its algorithms to determine load balancing. Now, the elephant in the room is NLB is free. Are there any downsides to it? Well, I mean, it's nice for a small to medium shop because they can deploy an N-tier business application and easily, literally just by installing NLB, clicking the mouse a few times, or running a couple PowerShell commandlets, you can set up a pretty nice amount of load balancing across that array of web servers. You don't have to buy a hardware load balancer, which is the other way to go. Certainly Cisco, F5, there are plenty of businesses who make their living by producing appliances, hardware load balancers. And you can put those in front of your web servers. And their algorithms are going to take much more into account than NLB does. One big Achilles heel of NLB is that it operates only up to the network layer. It's concerned with IP services. It cannot detect the status of your web application, and that's something that hardware load balancing solutions have more intelligence to do. In other words, you could have, say, a 3-node NLB cluster, and the web app on node 1 has crashed, let's say, so it's unavailable, but the IP stack is still functional, so those heartbeat messages are still flowing. This means that the software NLB that comes for free in Windows Server is still going to continue routing traffic to a node that we understand has a failed web app. You see what I mean? So NLB is certainly not a cure-all. The fact that you get what you pay for, and this being a free solution, needs to be taken under advisement. Now, I mentioned the term heartbeat. Heartbeat is a key point of any cluster solution. It's an internal communications method that your cluster nodes use to query each other to make sure they're alive. And again, that's not working at the application level. It's working much lower on the OSI networking model food chain. So every 1 minute, these cluster nodes exchange heartbeat messages to determine who's still in the cluster. If a cluster node misses 5 consecutive heartbeats, that node is automatically removed from the cluster, and then traffic is routed by the NLB stack to the remaining alive nodes. As I said, you have, as administrator, the ability to assign manual priority settings to favor a particular server. You might not be concerned about the mathematical algorithm stuff and affinity rules. You just want 60% of your traffic going to this node and 40% of your traffic going to the second node, and so forth. Another thing to consider with NLB is what type of traffic is being load balanced. With port rules, you can specify port numbers, TCP and/or UDP ports that will be load balanced. By default, the port rule is wide open, which is not particularly useful in most cases. If you're hosting a website, then you're concerned with TCP 80, maybe 443. If you're load balancing FTP, of course, you have those ports and so on. So we have the ability as an administrator, and you'll know how to do that by the end of this nugget, to configure those port rules. It's actually very important to do that because this is also where we can customize affinity. Now, for those of you who have wondered what's new and what's changed in Windows Server 2012, thus far, those of you who have used NLB in Windows Server 2008 R2 may be yawning, saying, well, I've been there, done that, bought the t-shirt. The biggest addition or change in Windows Server 2012 is robust PowerShell support, which should come as no surprise. PowerShell v3 in Windows Server 2012 has never been better. I'm a huge fan of it. And that's good news, frankly, because we really don't have a choice. Those of you who are not so much into the command line, I would strongly encourage you to revise that opinion and gain proficiency with PowerShell. Certainly you need that knowledge for your certification exams. These new generations of Microsoft exams favor PowerShell heavily. Microsoft wants us to use PowerShell, and the good news there, the reason why I don't mind having this foisted on me, is that PowerShell is a legitimately wonderful tool for administrative automation. It's really cool. So the name of the PowerShell module is pretty long, as are a lot of PowerShell names, Network Load Balancing Clusters. And we have 35 or so NLB-related commandlets. You can set up everything with your NLB just by issuing some PowerShell. You don't even need the GUI at all. From what I understand, Microsoft has a directive to the Windows Server product teams in which they need to provide a PowerShell module that gives administrators command line administrative access to whatever technology is under consideration. And definitely NLB is an example of a Windows feature that's well covered PowerShell-wise. A common question that comes up with Windows NLB is, how does NLB differ from DNS round robin? You'll recall that DNS, of course, is our client-server technology for resolving host names or friendly computer names to IP addresses. DNS round robin is a technology enabled in Windows DNS by default that will return a client's query with a list of matching A records. So in other words, if you want to provide some level of load balancing for your web servers, you may create, let's say you have 3 web servers, and each has their own address, .2, .3, and .4. You would create an A record for each one of those using the same host name. So let's say we've got 3 records, web, web, and web. So when a client connects to web.domain.com, whatever, the DNS server that's authoritative for that zone will see I have not 1, not 2, but 3 A records, and it will hand them to the client in a random order. So the first client might get 234, the second one would get 342, the third one would get 432. You see, so it's very rudimentary. There's essentially no intelligence there, but the idea is at least you're shuffling the deck and not hitting one web server exclusively. It's kind of cool, really, when you think about it. So the biggest differentiator here is that there's no intelligence. There's no priority or fault tolerance here. There's no way that these three web servers can detect who's online. In fact, they have no knowledge of each other. So management-wise or managerially, DNS round robin is a pain. You're going to have to modify your DNS zone if you need to take a box offline for maintenance, etc. Now, Microsoft best practice with NLBs is that you can combine round robin with NLB in the following situation. Let's say you have multiple data centers or physical points of presence, and you're offering a client-server solution, a line of business app, and you've used NLB clustering to balance the load on your front-end servers. So you would create an NLB cluster in each of your points of presence. All of them are mapping to the same name, remember. And then you can enable DNS round robin for each cluster. So you're taking the idea of round robin to another level. So you'll have multiple cluster IP addresses, and you'll hand those out with round robin. Now that could have some problems, of course, geographically. If you have a data center in Asia and another one in Europe and another one in North America, you might not necessarily want to give an Asian client a North American IP address and so on. But that is Microsoft's answer to the question of intelligently combining NLB clustering with DNS round robin. Network load balancing requirements. Let's look at what's required for us to deploy an NLB cluster in Windows Server 2012. First of all cluster nodes need to be on the same subnet. The subnet can be IPv4 or IPv6. I'm going to add an addendum to this, at least 2 NICs. Now, depending upon the operational mode, which we'll talk about in a second, the requirement for multiple NICs is either mandatory or optional. We'll get to that in just a minute. You want minimal latency between the hosts. If the hosts that are going to comprise your NLB cluster are on the same IP subnet, then it shouldn't be a big deal, but Microsoft says less than 250 milliseconds. Now the reason for this, of course, is that we don't miss heartbeats. If we miss 5 heartbeats, then a node is going to be automatically removed from the NLB cluster. Third, and this is a little known fact, you can combine different editions of Windows Server 2012 in a single NLB cluster, and that's fine. If you happen to have standard data center running in the same environment, you could use those. However, the gotcha is you do want near identical, if not identical, loadouts on those boxes, especially as regards to server roles, features, line of business software. For instance, if you're setting up SharePoint and you want multiple SharePoint front-end servers, hopefully it makes sense that you want to configure those to the same OS patch level, the same SharePoint patch level, the same connectivity strings to the back-end database. Hopefully that should make sense, because after all, your NLB cluster nodes, theoretically it shouldn't mind, or it shouldn't matter whether the same person connects to all of your nodes in a single session, because each node is hosting the very same content. Okay, I mentioned this a couple times thus far, operational modes. You'll see this, how this works in the interface in the demo. Here's what you need to know. Network load balancing can function in these 3 modes. Unicast, which is one-to-one IP communications. Multicast and IGMP multicast both are one-to-many IP packet exchanges. What do you need to know? Well, if you're going to do unicast operational mode, then what happens is all the nodes in the cluster use the same virtual MAC address. So network load balancing will actually overwrite in the registry the MAC address of each of your nodes with a shared cluster MAC address. Now what's the problem? Well, the problem is each of your nodes appears to your switches as the same box because they're all using that virtual MAC. VMAC, I'll call it. That'll work, but the nodes will not be able to communicate with each other in the absence of an additional second adapter. So best practice with any kind of clustering is to have at least 2 network interfaces. One that's outward facing to your user population, and another one that's used simply and strictly for internode communications. Okay? Now, multicast and IGMP multicast are different. There, each node maintains its own MAC address. So the upshot is the nodes can communicate with each other because, of course, fundamentally, in Ethernet networking, each network interface card has to have a globally unique media access control or MAC address, and they do. In a sense, NLB performs a NAT-ish, a network address translation, NAT-ish function by using virtual MACs and translating them back and forth with the host's or station's own MAC addresses. So you can actually get away with a single NIC in each of your NLB hosts if you use multicast. IGMP, Internet Group Message Protocol multicast, if you're going to do multicast, might work because it's going to prevent the switch from the port flooding that can occur with other operational modes. So in other words, when we use IGMP multicast mode, the connection traffic is forwarded only through the switch ports that participate in the NLB cluster. No other switch ports are involved. If there's a gotcha to IGMP multicast, is that your switch hardware has to support that functionality. And actually, to that point, even straight up multicast requires that your connectivity fabric, your switches and routers, support multicast MAC addresses, which most should by default anyway. Now, I mentioned that port rules represents the chief way that administrators can get in there and make NLB work your way. The idea with port rules right off the bat is that we can cut down on the muscle or overhead that the NLB is being asked to load balance by looking only for certain port IDs. For instance, web services, 80, 443, etc. across your modes. And there's two sub-customizations besides just cutting down on the ports that are being load balanced. We have what are called filtering modes and client affinity. Your main options for filtering are multiple host or single host. With multiple host, you're letting NLB determine the weight or the priority of each node. And NLB will use performance characteristics of each host to determine relative weight. The multiple hosts filtering mode is cool because it increases both scalability and availability at the same time. Single host mode is where you as an administrator provide an integer value to assign node weight, and lower values are actually higher priority. So if you have 4 nodes assigned 1, 2, 3, 4 respectively, 1 is considered highest priority, 2 second, third, and fourth. So if a node assigned the highest priority is unavailable, the next one manages the next bit of incoming traffic. Single host rules will increase availability, but they don't increase scalability. Scalability means a single host being able to support more connections. The second bit here is what's called client affinity. Now, affinity is a $5 word. It simply means preference. How does the NLB cluster distribute requests from a specific client? Now, affinity settings are relevant only when we're using multiple hosts, which is really the best way to go because, at least in my humble opinion, right? Because the idea is we're relying upon NLB to provide node priority instead of us having to get in there and micromanage it. Now, the 3 options here are none, single, and there's a third that I don't have on the slide called Class C. By the way, I'm sorry about these pop-ups. I'm using a Wacom UX21 touchscreen monitor, and I need to tweak up the customization of my stylus pen because my finger keeps spastically hitting the button and invoking a shortcut menu. So sorry about that. You won't see that in future nuggets, I promise. So Class C is the third client affinity option, and here's the difference between those. None, you're essentially saying no affinity. Any cluster node can respond to any client request. This is great for traditional non-sticky stateless web applications because truly for each connection a client could be directed to any node in the cluster. Single affinity is best used if you do have a stickier environment. In other words, a web application that does rely more on persistence. Microsoft Link Server, Link 2010, their front-end services are fairly sticky, actually quite sticky, to the point where Microsoft will oftentimes recommend, if you read their white papers closely enough, they don't want to sabotage their own products, but they'll recommend that you go with a hardware load balancer rather than roll the dice with NLB. But basically, single means you've got a one-to-one connection. A single cluster node will handle all the requests from a single client. So I hope you can immediately see the differentiation between none and single. If your apps are more stateless, go with none. If they're stickier, go with single. And Class C is best used when you're load balancing web servers facing the public internet and you have connectivity coming from literally all over the world. What happens here is NLB will look at the Class C subnet block of incoming connections and will assign them to a particular node based on their subnet block address. And this is good again for more sticky, stateful applications, and even more so when you've got clients coming in from a proxy server. I mean, think of it this way. You've got 100 users from Corporation A hitting a proxy, and that proxy hits your NLB cluster. As far as your NLB cluster is concerned, that's just a single address block, isn't it? We have all these connections, and they're going to be routed to a single box. That's actually more of a downside than anything else, because remember, the whole purpose of a proxy server is to mask connections and basically act on behalf of multiple connections by presenting a single IP address. The final point I want to address with you before we go into the demo is deploying NLB in Hyper-V. Can we do this? Can we set up an NLB cluster in a virtual environment? And the answer is yes. The best practices from Microsoft on this are, number one, redundancy is the rule. The whole idea of virtual infrastructure is we have agility, don't we? And if we combine Hyper-V virtual machines with a high availability solution like failover clustering, you'll see more how that works as we move along with this training series. We have the capacity to give both failover, scalability, and high availability for our virtualized web hosts. So what does redundancy mean here? Well, one thing you can do is place the node VMs on separate Hyper-V hosts. So you're separating them. Instead of in failover clustering with Hyper-V, what you can do is place your VMs all on one host, or you can spread them around to different Hyper-V servers. Of course, if you want to ward against the failure of one of your Hyper-V hardware hosts, you're best spreading those NLB cluster nodes across multiple Hyper-V hosts. Storage layer as well. Your VM VHDX files, your virtual hard disk files, put them on separate physical disks. This works equally well in a non-clustered environment or a clustered environment. In a clustered environment, you could store VMs on separate iSCSI LUNs, and you can use cluster shared volumes as well. We'll get to that more later. I don't want to get too burdened with new stuff at this point. And of course, another great benefit of a virtualized environment is that you can bring up things like additional NICs with literally a PowerShell commandlet or a few clicks of the mouse. Their third best practice from Microsoft is to specify unicast mode and deploy a second NIC for each of your NLB node VMs and connect that to the Hyper-V private virtual switch for internode communications or heartbeats. As you'll learn later in the course, Hyper-V relies upon this concept of the virtual switch to provide networking between your virtual machines and also between your virtual machines and the Hyper-V host, and then finally between the virtual machines and your local area network or even the internet. You have an external virtual switch that's used for the internet and LAN scenarios, and you can also deploy a private virtual switch that's usable only by the VMs themselves. Okay? Alright, enough talking. We need to get into that demo, and I'll show you how this works from soup to nuts. Hey there! Welcome to this demonstration on network load balancing in Windows Server 2012. In introduction to our topology, we have two Windows Server 2012 boxes, DC Nugget that's at 10.0.0.1. We also have a member server named MemNugget01 that's at 10.0.0.2. And we have a Windows 8 Enterprise Edition workstation that I don't have BG Info configured for, but it's at 10.0.0.3 and is a member of the Nugget Lab domain. First thing I want to show you is DNS Round Robin. Because it's so commonly confused with NLB, I figure it would be a good demo to show. Now, DC Nugget as a domain controller obviously has DNS, so I fired up the DNS manager. And what we'll do is look at the server properties for this server, navigate to the advanced page, and you'll see that both round robin and netmask ordering are in fact selected by default. So this is where the options exist if you had any concerns. Next, we'll navigate to our zone in question, and I'm going to say, why don't we use round robin to send traffic to either Nugget Lab or MemNugget1. Both servers are actually hosting IIS websites. In fact, why don't we press the Windows key to jump over to the start screen, fire up Internet Explorer. We'll browse first to the default website on DC Nugget. Next, we'll browse to the website on MemNugget. Now, of course, you can't really tell which is which other than looking at the address bar, so we're going to make a modification to this default image in just a moment to make it clearer. In fact, why don't we do that now? Let me do Windows R, and we'll go to the default content location in IIS. It's inetpub www-root, and I'm going to modify the IIS 8 ping image. We'll right click and select edit, and I'm simply going to use Paint here to put the host name of the box in. Doesn't matter that this looks stupid, it's not production. And now we'll do the same thing. We'll use Universal Naming Convention to hit the administrative share of MemNugget and go to inetpub www-root. Again, we'll right click and edit, choose the text tool in Paint, MemNugget 01. We'll save our change, close out, and now if I refresh, you see MemNugget and DC Nugget respectively. Now a trick, we can force a hard refresh instead of using the cached page on our computer by doing Control F5 or holding down the Control key when we use the refresh button. Okay, so to do round robin, we're going to need a host record for each server, but they map to the same name. You see, we have our host record for MemNugget and DC Nugget. I'm going to right click, create a host, let's just call it web, and the first IP address will go to DC Nugget. We'll hit add host. Now we'll do web that goes to 10.0.0.2, and that's all there is to it. Let's go to CleanNugget now. We'll fire up Internet Explorer, and let's browse to that shared address, HTTP web. It hit DC Nugget. Now what happens if we flush our DNS cache? I'll open up an administrative command prompt, ipconfig flush DNS. Now let's come back, do a control refresh, do a hard refresh, and we're now at MemNugget. So it's simply shuffling the deck, as it were, between those two hosts. That's round robin for you. So let me delete these guys, and now let's get into network load balancing proper. Now to do the installation, it's a simple run through Server Manager, or we can use PowerShell. I want to make sure to give you both approaches. We're looking at the PowerShell ISE. To get there, you can press the Windows key and just type ISE to bring it up in the apps list. ISE stands for Integrated Scripting Environment, and this is a great platform for learning PowerShell and also for creating PS1 script files to automate your work over time. Now I want to draw your attention to line 1 here. The invoke command commandlet enables us to run PowerShell remotely, provided that we have administrative credentials on those remote boxes. We pass in a few parameters. Computer name is a comma-separated list. We actually can bring in a text file that contains a column of multiple names if we want to go that way, but here I'm just providing nug1 and nug2 as arguments. And then the command parameter allows us to pass in one or more PowerShell commandlets. The command or commands needs to be embraced within curly braces, as you see here, and I'm just simply running install Windows feature NLB and also the administrative tools for NLB. Simple as pie. The other way to go, of course, is through the Server Manager console. We can do manage, add roles and features, and we've been here enough to where you know the drill. I'll select the local server, and if we go to the features page, we have an entry for network load balancing. We'll bring in the administrative tools or management tools, of course, and install. I'm going to do this on both this box as well as MemNugget 01. The installation succeeded on both boxes, so we can close out, and then in terms of creating the cluster, let me bring up the ISE again. We can either use the new NLB cluster commandlet or use the graphical interface. Now I'm going to show you the graphical interface, and then the parameters used in new NLB cluster will make more sense, I have a feeling. We'll go to Tools, Network Load Balancing Manager. We'll maximize our view here. We don't have any clusters configured, so this little disclosure plus doesn't do anything if we click on it. Instead, we can right-click the root node to either build a new cluster or connect to an existing cluster. Of course, we want to create a new cluster. It asks us to connect to one host that is to be part of the new cluster. Well, that's going to be DC Nugget, isn't it? So we'll type the host name and click connect. It asks us for an available address. I have two interfaces, Ethernet, which is my physical NIC, and vEthernet, that's my virtual NIC. On this box, I have Hyper-V installed. And if you know anything about Hyper-V, you wind up with one or more virtual adapters. And I have an external virtual switch configured in Hyper-V, so thus I have an associated vEthernet that my IP address is migrated to. So I'll select that. It asks us to denote a priority level to this NIC. 1 to 32 are the choices. You can add multiple IP addresses if you need them. Remember, best practice with NLB is to have dedicated connectivity between your hosts for internal communications, and you'll need at least one IP address that's part of your LAN that's going to pipeline into the cluster itself. If you click Edit, it simply allows you to edit an IPv4 address. If we click Add, we can add a new IPv4 or IPv6 address to the cluster. The initial host state can be started, stopped, and suspended. We'll have more to say about the suspended state and a feature called drain stop in just a minute. We'll click Next. Now it asks us what is the VIP, or virtual IP, that the cluster will advertise. Remember, we have just a single virtual IP that's used by the entire cluster. I'm going to assign the IPv4 address 10.0.0.100 IPv4, and we'll click OK. Didn't like that. Well, of course, we need a subnet mask that matches that IP address. Let's click OK, and it liked that, and we'll click Next. We can supply an internet name for the cluster. I'm going to call this webserver.nuggetlab.com. Now, you might be wondering, are we going to automatically have this guy added to DNS? The answer is no. We're going to need to create a record for web server in the next step. Remember the cluster operation modes, unicast, multicast, or IGMP multicast. Well, in this simple example, my hosts, DC Nugget and MemNugget01, have just that single virtual NIC. So because I want them to be able to communicate with each other as well as with the rest of my network, I'm going to choose the multicast cluster operation mode and click Next. Here we have port rules, and by default, all listenable cluster addresses from port 0 to port 65535, which represents the entire address space for TCP or UDP ports, is going to use single host affinity. We're going to edit the port rules afterwards, so I'm going to leave this at a default and click Finish. Now you'll notice here that we have a little hourglass symbol as we're bringing DC Nugget and its vEthernet adapter up, and you'll see down below we have the event log entries that are relevant for this service. Shows you what's going on. So it looks like this guy is up and enabled. I'm colorblind, so I have no idea if this is red, green, or some other color, but I hope those of you who have color capability can determine that well enough, right? If we right-click the server and choose Add Host to Cluster, we can bring in MemNugget2, or MemNugget1, excuse me. We'll make a remote connection to that box and select it. It's also a Hyper-V host, so we're going to use the virtual Ethernet instead of the physical Ethernet adapter. This guy gets picked up with the next host priority by default. That's fine. I'll make its initial state started. We won't do anything with port rules yet, and you notice it doesn't ask us for a cluster address because it's implied that any host underneath webserver.nuggetlab.com will be part of that cluster. Now before I forget, I better bring up the DNS manager. Let's right-click and refresh the view to verify that we do not have an entry for web server. So what we'll do next is right-click in there and choose New Alias, or excuse me, New Host. This will be an IPv4A record. Web server that uses the IP address 10.0.0.100. We'll add the host, and there you have it. Let's right-click and reload the zone, and just for good luck, let's right-click and clear the server cache. And what you want to see in your cluster is a status of converged. That's a good thing. That means that our NLB cluster is operational. So we've got a 2-node system running right now. I guess it's time to test it. Let's come over to CleanNugget. Again, I'm going to flush my DNS cache, and we'll fire up a new instance of Internet Explorer. I need to change the default home page. Let me go to Settings, Internet Options, About: blank. If you're like me, you don't like Internet Explorer jumping to a page every time you start the browser. And we don't need the HTTP prefix, but I'm going to add it just for good luck. Web server is the host name, and bang, we instantly are connected to DC Nugget. If we do Control refresh, we continue to get references to DC Nugget. Well, that should make sense. Single affinity means once this client's connected to a particular host, it will stay stay connected to that host. Let's go to MemNugget and fire up Internet Explorer, hit that same address, web server, and wouldn't you know it, we hit memnugget01. No big surprise there, right? That's really all there is to it, friends. Back to DC Nugget now. Let's bring up our PowerShell ISE because, as promised, I wanted to show you the new NLB cluster commandlet. To build a new cluster, we specify just basically the same answers to the questions that we received in the graphical interface. We have to specify one interface that will be part of the cluster. That would be the local whatever machine you're currently on. Presumably we'd do this on DC Nugget first, and we would specify vEthernet as our adapter. We can specify our operational mode, cluster primary IP, and the cluster host name. That should make sense to you, right? To register the DNS record, you can do that easily. Invoke command computer name web, which is the cluster name. And then in the command portion, we can do add DNS server resource record A and put in that. So essentially, everything we've done in the GUI so far using the networking load balancing manager and the DNS manager console can be done with a couple lines of code. Finally, the third thing we did was add a new cluster node. We can do that in PowerShell very easily with the add NLB cluster node commandlet, specifying again the Ethernet friendly name for the interface, the new node's name, and the new node's interface. By specifying the cluster interface name, the new node's host name, and the new node's interface friendly name, and you can bring it in. Now, as far as management of an existing NLB cluster, you have the old-fashioned way and the current way. Old-fashioned is used to WLBS. This is a command line tool. If we run WLBS without any parameters or using the question mark switch, we can see what's up. Display and query are probably the ones that you'll use most commonly. Display gives you your configuration loadout. Query displays the current cluster state for current members of the cluster. You can suspend, resume, start, stop, drain, stop, enable, disable. You can do everything with the cluster using WLBS. So WLBS display, as I said, just gives you a dump of everything going on with your cluster, including port rules. That reminds me, we need to modify those. Let's come back to the graphical interface, right-click the cluster, and go to Cluster Properties. Here we have a tab called Port Rules that we can edit the default rule. We could select either all or just specific cluster IP addresses. Because I'm using port 80 here for standard HTTP, I could do from 80 to 80 TCP. To be safe, I'm going to use both here. And then we get into single host or multiple host, and then affinity for multiple host. We remember how this works. I'm going to change the affinity to none because this is a completely stateless website I have here. The IIS default website is just that single page that shows the IIS 8 logo, and it doesn't matter a whit whether I'm connected to DC Nugget or MemNugget. Click OK and OK, and the status is going to go to pending until it reconverges, and we see there's an intermediate state of converging, and even though in my color blindness I can see that that's a yellow tinge, so that's kind of cool. Now, what about taking a node offline for maintenance? This is something that you may have to do to apply a patch and reboot a box, replace a piece of hardware, whatever. The way you do that is just right-click the node in question, come down to Control Host, and you could just actually stop the node or drain stop. Now, drain stop is particularly cool. It's important to know this for your exam. Microsoft likes to test on these kind of things, and also in your production environment. You may need to take MemNugget offline temporarily for maintenance, but what about the users who are currently connected to that node and who are doing work that they don't want to lose? If we do a Control Host stop or a WLBS stop, that's going to immediately terminate the connections. And yes, they'll be redirected to DC Nugget, but depending upon the stickiness of your web application in question, this could have negative consequences for the users. So drain stop is an excellent method for bringing a box offline gradually. It will not allow any more connections to that node, but it will allow any existing connections to terminate gracefully before the node actually goes offline completely. We can also suspend or resume, which is a less aggressive way to start and stop a host. Now I'm going to get a little more aggressive still, and I'm going to go into the IIS Manager and stop the website from there. So we'll do a Tools. I'm on MemNugget, as you see. IIS Manager. Over on CleanNugget, I've just done a hard refresh to the web server cluster address, and I'm now connected to the MemNugget instance of the site. If we come back to MemNugget, I'm going to select the server in the IIS management list, and I'm going to stop that guy. If I right-click again, I see that Start is my available option. So this site is offline. Come in, hard refresh. I've gone over to DC Nugget. Come over to MemNugget itself, the actual failed server, do a hard refresh, and we're redirected to DC Nugget. If we restart the website, that cluster node will come back online just fine. Same thing, control host, start or stop. You can do it from either location. And because our port rules are scoped for port 80, Network Load Balancing Manager was able to see that connectivity to MemNugget 01 was perturbed because I had shut down the IIS service on that box. So there you have it, friends. Configuring Network Load Balancing, or NLB, in Windows Server 2012. Well, I certainly hope that you're more comfortable with NLB than you were before you watched and studied this nugget. Let's review what we should know by now. We should now be able to define NLB, understand what it's used for in business, how it helps, what some gotchas are with the technology, and very importantly, how NLB differs from failover clustering. That's crucial, friends. You need to understand that difference, and that difference has been fully elucidated by now. You understand the prerequisites, the requirements, and best practices that Microsoft gives us with regard to planning NLB. And you also, this is very valuable, understand now how to implement an NLB cluster using both the GUI tools, Server Manager, etc., and also PowerShell. In so doing, we came across this arcane terminology, didn't we? Things like port rules, again I have the old English F, we have affinity, operational modes. That stuff should all be familiar, and you should understand the hows and whys of when and why we would enable or disable any of those options. Good job. This is not particularly easy stuff, and we'll just continue to go from here. I hope this has been informative for you, and I'd like to thank you for viewing.